Hello, let's continue our Sudoku adventure with Ratio Difference Adventure by riffclown. So we have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we're placing the digits 1 to 6 exactly once each. Additionally, we have these black dots with the 3 in them to remind us that actually in this puzzle, it's a 1 to 3 ratio, not a 1 to 2 like we're used to. So one of the digits is exactly 3 times the other. So for example, if this was 6, this one would be 2, because the 6 is exactly 3 times 2. Additionally, we have white dots, and there's a 2 in them to remind us that in this puzzle, it's a difference of 2 instead of our normal difference of 1. So if this was a 2, this could be a 4. All right, so those are the rules. Definitely check the description to try the puzzle yourself first, and I am going to get started right now. All right, so the first thing I'm going to do is just highlight every ratio of 3, because in a 6x6, we can only do 1, 3, or 2, 6. So I think that's worth marking. You can see down here, this given 2 has actually eliminated 2, 6 as an option, so it's only 1, 3. Now this is a trick that you see a lot with dots, where these 2 dots are in the same column as this one. And so what would happen if this was 1, 3? Well, we'd have 3 cells for 1, 3 in the column, which just is not allowed. So it's not 1, 3, it is 2, 6. And that looks down at this, removing 2, 6 as an option from here, because this cell can't be 2 or 6. All right, and so now we have a pair left in this column, only 4 and 5. And in fact, we could have known that from the start, because 4 and 5 can't go on these black dots, because you can't divide 4 by 3 and you can't multiply it by 3. 12 is way too big. Same with 5. 5 is prime, you'd have to multiply it, it would be 15. So 4 and 5 in this column would have to go here because the rest are on black dots. So that's a nice little trick you can do. So let's look at here. Only one of these is going to work. It's the 5, because these white dots actually preserve what we call parity, even oddness. This is only odd, so this can only be odd. Obviously, you can also just look at the numbers. But anyway, this is 5, 3, and 1. This is 1 and 3 and 4. Some nice flurry of digits there. Now 1, 2, 3 have to go up here. So the 1 and 3 are going to go here, and this is going to be the 2. 2 can only go with 4 on this white dot. Here we're going to have 4, 5, 6, and the 4 is going to go here. Here we need 4 and 6. Don't know the order yet. 4 is going to go with 2 or 6. Might as well fill that. All right, so what do we have left here? Let's do this row and this row, maybe. Oh, actually, this 2 is looking up here, and that places the 2. So I didn't even have to use that dot. Let's see, what else? Yeah, let's just do these 2 rows then. So I need a 2, 2, 5, and 6 here. That's not a 2. And this is going to be a 5, 6 as well. That looks down. That gives us 4 and 6. And this is going to be 3, 5, 6, it looks like. So what difference of 2 can we actually do here? 3 can go with 1, but actually that doesn't work because we have a 1, 3 cell here. If I do 3 and 1, that is going to break that cell. So we can't do 3 here. Can we do 3, 5? We can do 3, 5. We just can't do 3, 1. We can do 5, 3. We can't do 6, 4 because of this 4 here. So actually this is going to be a 3, 5 pair. We don't know the order, but that does look down, removing the 3 from here. And it removes the 5 from here, if that's helpful. So this is the other 2, 6. Oops, 2, 6 for the column. All right, what else can we do here? This column is 3, 5, or 6, and the 3 is in one of these 2. So that actually claims the 3s in the rest of the box. So this can't be a 3. This is a 5. This is a 3. These are not 5s. So the 5 in the column goes here. That's a 6. That's 5 and 2 and 6. Nice. Looks like we have cracked it. 3 and 6 there. This is a 1. And then I need a 5 and a 1 up here. And I need a 4 and a 3. They go like this. And I have the correct solution. Nice. So thanks, riffclown. That was a fun puzzle. I like the demonstration of a few different tricks you can do with these. Specifically, having a dot that points at one of the cells, where both of them point at one of the cells, and that means they cannot be the same 2 digits as each other. And then also, like if we looked at this column here, seeing that this had to be a 4, 5 pair was pretty nice. The parity being preserved across these dots is a nice way to think about things. So hopefully you learned something here. And of course, if you enjoyed this content, then why not leave a like and subscribe?